Okay, and today we'll be talking about where we left off yesterday in usability, and then if we have time, we'll be moving on to acceptability and engagement. But first, Josh just wanted me to talk to you guys about a little bit about me and give you guys an opportunity to ask questions about what it's like to be a PhD student, or if you're a master's student or undergraduate student, how you make the transition or what that's all about. So my name is Joshua Powers. Let's see, I'm a fourth year PhD student or third year. I don't know, I've been a PhD student for a while. And I work in Josh Bongard's lab. We do lots of things with robots, designing the way they look with algorithms, so automatically designing the robots. We also do this with soft robots. So this is often called evolutionary robotics. And I'd say in general, we do lots of artificial intelligence-based things, but they are non-traditional artificial intelligence-based things. Often looking at the way unintended design factors might affect a robot. So particularly if I have a robot with sensors on it and I place the sensors in a different position, how does that help or hinder the ability to train an AI algorithm on that robot? Might be an example. So let's see. Yeah, so been a PhD student for a while. I'm from Utah, so I was out in Vermont. I also have a family. I have a wife and 3 kids. So I also have experience with doing school while having a family, if that would be anyone. I know that's pretty rare. So yeah, does anyone have any questions about what it's like to be a PhD student, or anything specific they'd like to know about what PhD students do, how we spend our time, what it's like during the day, what our class is like? I don't know. You can ask anything you want. Okay, so Joseph asks, where did I do my undergrad? I did my undergrad at Brigham Young University, just a university in Utah. And I did my, it was in computer science. So I'm doing my PhD in computer science. My undergraduate was also in computer science. Let's see. So Oliver wants to know how PhD classes differ from undergrad classes. So I would say, so obviously you guys could take PhD classes if you wanted to. I'd say the biggest difference between a PhD class and an undergrad class is often a PhD class is focused on getting you to a point where you can discover something new about a topic. So if you take Safwan here has a class in deep learning. So if you take the deep learning course, you're of course going to learn all about the deep learning that's already out there. But then by the end of the course, the hope is that you can take those tools and maybe come up with an application for deep learning that's novel, or often you'll have your own research that you can take the applications for deep learning and use it in your research in a novel way. And so the focus is generally on the end of the class by doing some sort of project that's more open. And that's usually the biggest part of the class is I'm gonna take whatever I've been learning this class, do something new. It's very open-ended, and I'm gonna have some sort of write-up about it. And that's usually the biggest focus of the course. And I'd say that's the biggest difference, is just a focus on pulling this knowledge out into some sort of research project. Nana asks, I hope I'm saying that right, Nana or Nana, it's probably Nana, huh? Sorry if I'm saying it wrong. She asks, what was your motivation? And I would say my biggest motivation for doing a PhD is I didn't want to be like just a software engineer. So, and I had a little experience seeing, you know, how companies worked and stuff. And I guess, you know, not that you're not doing novel things as like a software engineer or a web developer, not that things aren't novel, but in a way, a lot of the problems are solved in a sense. It's like, yeah, well, I just need to use this algorithm or like someone's done this before or something very similar, and I'm just trying to code it up. So a lot of the emphasis is on can be on maintaining things or on building things that are it's very clear how it's going to be made. And I was really interested more in just you know, doing things that hadn't been done before. And I had taken some graduate courses as an undergrad, and I really enjoyed those and kind of the way that had worked out. I had also worked in so you can work like in a professor's lab as an undergraduate helping the other PhD students. And I also did that, and that was very interesting to me. So I had just really enjoyed that kind of work as I had tried it out compared to what traditionally is happening in if you just take a job out of, you know, right out of graduation in the industry. So yeah, so that was my main motivation. That's just I just kind of enjoyed it, and that's what I kind of wanted to do. I wanted to get a PhD and do that kind of work at a company or be a professor and do that kind of work. At first, I wanted just to do that kind of work in industry, right? I wanted to work in like an R&D lab at a big software company. I don't know, Google, Microsoft, Apple, whatever. But as I've been doing it, I also have now moved to plan. You know, my first choice being actually being a professor and running my own research lab at a university and teaching classes. So sorry, that was a long answer to the question. All right, Alex asks, what made you decide to come to Vermont? So I didn't pick Vermont because of the school. I picked it because of Josh Bongard. So there's kind of two ways you can there's two ways you can pick where you want to do your PhD if you're wanting to do one. One is, or I guess there's three ways really. There's three things to consider. One is the school, and in my opinion, that is in some ways the least important, depending on what you want to do. But like, for instance, yeah, so it's kind of the least important, and I'll explain why. Because the next thing is who the advisor is. And that's really the most important thing. So I picked Josh because I feel like the work he does is really interesting, and you can kind of look up researchers. So you can go to Google Scholar and look up researchers. And Josh has a great, you know, he's done a lot of research. There's little numbers that tell how good research. So he's a good researcher and stuff. And I was interested in the work he does. And so I reached out to him and talked to him, and really, I just felt like I really enjoyed the way our talk went and the way he talked about he would advise, right? So there's different ways. Some advisors are very hands-on, some advisors are very hands-off. So it's really kind of a personal thing, and it's hard to know going in because you haven't been a PhD student before, right? So it's hard to know if you're really going to like that advisor's personality or the way they work. But yeah, I would say that's the most important thing is, do you think you're going to like being advised by that person? And are they doing work that is important to the larger scientific community? And then second to that comes what school they're at, because the school they're at just kind of can bring prestige on its own. So so for example, you could go to Harvard or MIT or Yale, right? You could go to one of these places that like there's a lot of prestige attached with the name. So getting a PhD from there is a big deal, but that doesn't necessarily guarantee you're going to have a great professor that cares very much about you. So Josh is very interested in making us very successful PhD students. Some advisors are really interested in making themselves look better or more prestigious and not as concerned about their PhD students. So that's a possibility. I'm not saying that happens at a bigger school. I'm just saying, or at a prestigious school. I'm just saying those are things to consider. So I came to Vermont specifically so I could work with Josh. And then the third thing to consider is funding. So Josh also had funding available. So obviously you can pay for your PhD and you can pay lots of money. Or there's things called graduate, you can be a graduate teaching assistant where you get paid to like TA for classes, and that covers your tuition, and also you get a little bit on that. Or you could be a graduate research assistant where the professor, they've written up some fancy document, send it out to a government agency, and the agency's like, we'll give you money to work on this. So NASA might give you to work on something if you write to them and say, we have this great idea for these, I don't know, little robots that, they're really small and light, and they're going to explore space for us. And NASA's like, oh yeah, we like that. We'll fund you guys for 2 years to kind of work on this project. And then with that money, Josh would then go and hire PhD students or master students, and he would fund their education. So I guess that's another reason I came to Vermont, is Josh also had funding available. So it was able to cover my tuition and then pay me money to live on, which is obviously important because I have a family. So it'd be really hard to do your PhD and have a job. Yeah, so those are the three main things that I would say you're really concerned about when looking at a PhD, and that's why I came to Vermont. So let's see, looks like the last question is what the workload is like. This comes from, I don't think I'm going to say that right. Sidhanth? Sidhanth? I don't know. Sid, it comes from Sid. Good call. So Sid says, what's the workload like? It really depends. All the courses have vastly different workloads. So I've taken some of the PhD courses where I felt like I was spending, I don't know, maybe 6 hours a week just on the homework. And then I've taken some PhD courses where I was like, yeah, this only takes me an hour every week or 2 hours every week. And so it's really up to you. Granted, you only have to take, you could take up to 3 courses. So you take 9 credits a semester. And at the beginning, generally you split this up by doing 6 credits of courses and 3 credits of research. And then after you finish 30 credits of courses, you switch that all and you start doing 9 credits of research. But I mean, you can do it any way you want. So if you're really interested in the research project you're working on right now, you can say, you know what, I'm going to take 6 credits of research and only 3 credits of classes, or 9 credits of research and no credits of classes. You just have to make sure that by the time you're graduating, you have those 30 credits of classes taken. And you'll generally graduate in 4 years. So a good strategy, and it seems like most people do this, and or at least Josh encourages us to do this, is just to take 2 classes a semester at the beginning until you finish your 30 credits, and then just start doing the 9 research credits and spending all your time on research. And that seems to work out pretty well. But yeah, the workload is essentially how you want it. I think contractually, the way the workload works out is you're expected, 40 hours of effort, and you divide that 40 hours of effort between courses and research. So generally you have 20 hours of research regardless that you're supposed to be doing in your contract. And then you should be spending 20 hours on courses, including homework. And so so imagine like if you divided 20 by 9, that's how many hours you're spending per credit on non-research related things. But then if you're taking research credits, then you're like, well, I'm taking 3 research credits, so this 20 hours, so much should be research as well. So now you've got a little bit over 20 hours of research and a little bit less on coursework, right? A little bit less than 20. So it's really up to you. There's obviously the contractual way of doing it. It's not like someone's like monitoring you though, and like saying like how many hours did you work, or there's none of that. It's just and you can obviously like work extra 1 week and then take a little break on like a Monday, so you can split it up how you want. But in general, the idea is that you'd be working, that you'd be spending 40 hours of effort between courses and research a week. So just like a job in a way. Sage asks, what's the main thrust of your thesis? Do you collaborate with electrical, mechanical engineers for building, designing hardware? So the second question is, yes, we often work with a lab at Yale who builds, they do, so we do a lot with soft robots. So personally, I collaborate with a lab at Yale who builds a lot of the robots. So we'll kind of design some of them in simulation, train algorithms on them, and then transfer those to the real robots that the Yale team makes. But then there's also other collaborations in our lab, like one of the PhD students, Sam, he works with, show video clips. Oh, that's David. David is in our lab. Maybe I'll show a video clip, but okay. So there's other ones like Sam, he's a PhD student. He works with a team at Tufts, and they kind of do a biological substrate of cells for the robot. So simulating cells, and then you do the thing with the cells in real life. We've also done collaborations before where we've had, I guess, like we had someone from Australia come who worked for the Department of Defense in Australia, and they did kind of small ornithopter-like flying robots, I guess. So, I mean, there's lots of different ones. In the past, sometimes we haven't had collaborations and it's just been in simulation, so no hardware substrate. So there's lots of different research areas. And then the main thrust of my thesis is so the main, I guess, I'm researching is how small design changes affect. I kind of talked about this a little bit when I said what we do. I really kind of was saying what I do. So my thesis is about how small design changes in robots change the learning aspects of a robot. So irregardless of the method used to teach it to do something. So again, I've done things where, you know, if you have a quadruped and you slightly increase the strength or the range of motion of its limbs or the weight or the size of it, how does that affect its ability to learn a problem, and what are the different ways we can measure if it's affecting it? And then the second part of it is, if these things do have big changes, which so far what we found out is they do actually make big differences in the way learning algorithms operate on a robot. So they do make big changes, and there are ways to measure those changes. The question then is can we create algorithms that automatically can design robots that maximize these things such that the algorithms are easy to learn, they're fast, the robots learn, you know, so the robots can learn problems easy, the robots can learn problems fast, so it's efficient, and then the robots are robust. So if if they encounter a problem that's slightly different than the problem they're already good at, are they also good at that one? Or if the environment slightly changes. So that's kind of where my thesis is solving those things. I don't know if you guys can hear that. It sounds like the Echo device is going off. What's that one's name? Alexa. Alexa is trying to talk. Okay. I will show some video clips for the sake of David, if I have any. I think I do. I have one of my recent paper. Let's see. So let's start playing that, and then I need to switch which screen I'm sharing. Can I just switch it, or do I have to? Oh, I think I have to stop sharing, and then. Okay, and let's see. So you guys should be seeing something that says gaining environments through shape change. I don't know how videos work over this. I hope it doesn't like lag or anything. So this is a recent paper we did, gaining environments through shape change. Essentially, we have a kind of like a cylinder robot made out of silicone with these bladders on the outside that cause it to roll. So this is kind of what it looks like in simulation. And The idea of this is to show how shape change can be an effective substrate for operating in new environments. So here the robot can roll, and then obviously it can't roll uphill because that would be hard. And then if we try to like, learn a way to roll uphill, it obviously learns something better, even though it's kind of weird, but it's not rolling downhill anymore. So if we use the same algorithm and we allow it to change its shape, it deflates its inner core and then kind of learns this inchworm motion to move up a hill. Oftentimes optimization isn't perfect, and so we could optimize this longer to get rid of those, but sometimes it does things that aren't really beneficial or hurtful. So here's one that was optimized for rolling over flat ground. So a little different strategy. It's actually a little bit faster. It kind of exploits certain aspects of the simulation. And then obviously simulation isn't perfect. So here we have, it found a way to go uphill by going sideways. So here's the real robot that the hardware team at Yale built. It rolls. There it goes. Let's see, it's doing the same thing. It rolls, and then should speed up the video. I think they do speed it up a bit on its own. And then it's going to flatten here, change shapes, and then it's going to go up the hill. The on the end, you can see like these little black stripes. That's fabric, and then in between the fabric is silicone, and you can blow up the silicone to make it grippy, and then deflate the silicone on the end to make it slippy again. So here we go. This is 10 times speed. So it kind of moves like what moves like this? I guess kind of like a caterpillar. Yeah, cartoon caterpillars move like that. A Disney caterpillar moves like that. Anyway, so yeah, and then just trying it out in different areas. Let's see if the only one that's interesting here is, oh, they don't have it. They used to have one. I guess we didn't keep it in this video. We used to have one where we show it. You always have to light your robot on fire. So I don't know where that is, but we used to have a video of lighting it on fire too, because that's always fun. All right, so let's go. Okay, any more questions before we move on to actual class? All right, I think we'll move on to class then. It's kind of weird presenting in this format though, because all the time I'm wondering, it's kind of funny. I kind of sit here going, I think maybe my video cut out. How do I know it's still working? How do I know they're still hearing me? In the class you have everyone's eyes, you can see. It's kind of interesting. Okay, so last time, this is where we left off. Let me get my other computer up so I can see the special red text too. Okay, so this is where you left off last time, I believe. If not, someone stop me. So last time you ended off talking about the early focus is on, let's see, users and tasks in this kind of usability process. Let's see. Include users early in the design process. Taking empirical measurements. So you talked about how there's actual things you might be able to measure to, that are objective things, not subjective, that you could measure about how a person is doing with, I think, the leap motion device, and to figure out if things are working the way you want, or if the device is usable, right? We talked about iterative design, that we want to do this very rapidly, repeatedly, build on things little by little, and then we're optimizing all these things together. I think these are the things you're optimizing: efficiency, effectiveness, easy to learn, right? So you want to optimize all of those things together, and oftentimes those things are interdependent. So improving one can make the other worse. So let's see, what are some examples of this? Is there an example where you could, maybe you make something more efficient, but that makes it harder to learn or less safe? So these are kinds of things we're thinking about here. If we're improving one thing, does it adversely affect the other? One of the things I can think of maybe that I deal with is some software I use. So some software I use, it's really efficient. So a lot of it is like engineering software. Like, it's really efficient for engineers and it's quite effective. But because it's efficient for those people, it's effective for those people, it has high utility, right? High utility for those people. Because it has those things, it's really hard to learn if that's not where you're coming from, right? So it's a lot harder to learn for someone who doesn't know all the different terminologies of engineering. And it could be designed to make it really easy to learn, easy to use for someone who's not knowledgeable, but that would probably cut down on the utility for the actual target audience, which is like an engineer or something. So that's one way, improving one aspect can make another aspect more difficult. I think you might see this with a little bit, maybe something like Adobe Photoshop could be something that maybe people are familiar with, or something like that, right? If you're not familiar with photo editing, you open it up and there's all these buttons everywhere, and what do all these buttons do, right? That makes it not easy to learn, versus if like there was just like a couple, but it's made for professional photo designers. But then you can also get like an app on your phone, right? That, the one thing it does is cut out the background, and you don't really have to worry about, it does that feature really easily. You don't have to worry about all these other buttons. There's just like a couple buttons, a couple things it does. And so it's really easy to learn, but a professional photo editor would hate that, right? So there's like another example. You guys ended on this slide, so I do need to talk about these a little more. So the first one, the early focus on users and tasks. So we want to start including users early in the design process. This is because you don't want to go halfway through and then find out that the users don't like something. So you want to invite them in early on in what's going on, and repeatedly ask them how they like something. So you make a little something in code, you see what the user thinks about it. You make another little feature, you see what the user thinks about it, and you go back and forth early on. And then the empirical measurements, one way to think about empirical measurements, right? The things you can actually measure on the Leap Motion device, you might think of, let's see, like something you could measure is how long does it take them after turning it on to do something that I want them to do. So maybe what I want them to do is sign a letter or sign a number. Then I turn on the Leap Motion device. How long is it before their hand moves over the device? How long is it before their hand moves over the device and signs the letter? So you could measure things by time. And then we already talked about iterative design and kind of the usability, how improving one can hurt the other. Can anyone else think of anything empirically you could measure in your Leap Motion device to figure out if it's usable, right? So what are some things you could measure to actually figure out if it's being efficient or effective or easy to learn? What are empirical measures, something that's not subjective? Okay, so Alex says we can measure how far away their hand is from the device, right? So we'd like their device, we'd want their hand not to be too far away. Obviously, if it's too close, then it can't see anything either. So there is a height that we'd like, that you really should have your hands at when using the device, right? So that is something definitely that we could measure to figure out how usable our system is, or how usable the leap motion device is. Is it easy to learn in that someone can easily know how high to put their hand in? So you can measure how high their hand is or how long it takes them to get at the right height, right? So that is something that you could definitely, an objective thing you could measure when doing the leap motion device. Okay, so let's move on. So if all usability factors are optimized, then Josh likes to say that the technology becomes invisible and an activity becomes the focus rather than the technology itself. So for examples of this, that in this red box, I think you guys have like something you're following along with that you can write in. So examples of highly usable physical technologies would be something maybe like a hammer. So the reason he says a hammer is something that's extremely usable or becomes invisible, he says you can tell because it's become verbified. So you don't say, I am using a hammer, you say I'm hammering, right? He also says cars are an example of this. Not that you are carring, right? But there's a verb for it. I'm driving, not I am operating a car, right? So there's a verb that is specifically used for that task because the object itself has kind of become invisible. We don't ever talk about our operation of the car. I am turning the steering wheel. We turn, we drive. We accelerate. We don't push the pedal down with our foot, right? That's not what we don't tell people, oh, I'm going to push the pedal down harder. We tell people I'm going to go faster. So those are some physical examples of highly usable technologies. Other examples of this is like Google. Google's highly usable, and we say we're Googling, right? We don't say I'm going to type something into the search bar of the Google or of Google. It becomes a verb. I'm Googling. So that's something that you can kind of look to if you know that a technology is really usable. People tend to develop their own language around it that really makes what we're actually operating invisible itself. So, but if things go wrong, right, then this becomes very different. We start discussing what's wrong with the object. So you might, if you hit your thumb while you're hammering, oftentimes you don't say that you're bad at hammering. There's something wrong with the hammer, or there's something wrong with the car, even if you don't necessarily jump to I'm a bad driver. So this can be the same with Google. If for some reason Google crashes, you don't say, I'm not good at Googling, right? There's something wrong with Google. So a good technology that's usable hides itself, and technologies, even usable technologies, but in technology in general that are unusable or are failing, the technology itself becomes the focus. And so you have something usable when people are kind of pushing the technology out of the way and doing things in kind of a different manner than focusing on the actual operation of the technology. So what are some other examples of technologies that you guys encounter that you feel are very usable, that kind of hide themselves when you're using them? You don't focus on them. You just focus on the thing that you're actually doing. Any technology someone can think of? A spoon. Cole says a spoon. Let's see. I do agree, because when you use a spoon, you're just eating, right? You're not, oh, I'm gonna scoop this up. You don't say something like that, or I'm gonna use the spoon. You just, oh, I'm just gonna eat, right? I'm eating my cereal. An elevator. I would agree that an elevator also fits. Yeah, this is another good example. A TV, and then there's also examples of when these fail. Right, it becomes very apparent. So if any of you have been in, this is funny. I'm thinking of elevator right now. If you've been in the newer building, what are the names of those buildings? I forget. The new computer science buildings where this class would have been. It's Discovery and Innovation buildings. I know probably a lot of people have COVID right now, but in those buildings, the elevators are painfully slow. And so normally you get into an elevator and you're just like, I'm just going up, right? But not in the innovation building. You go in that elevator and you're like, wow, I'm in an elevator right now, and this elevator is not my favorite. So yeah, these are some great examples. A TV, a washing machine. I think all those things are good examples of things that have high usability. A washing machine, you're just washing your clothes. The only time maybe a washing machine you really think about what's going on, right, is if it breaks, or sometimes if what you have to do is special, right? So you're looking at your clothes and, oh, you can't just throw it in there. You have to do the gentle cycle, and you can't use normal soap. You have to use some gentle soap because it's wool or something, right? So in general, the washing machine is very usable. So maybe something that could make it even more usable is if you didn't have to tell it, right? You threw the clothes in and somehow it knew, oh, these are delicates, right? Then you could then even with certain types of items, you could be like, you could just, oh, I just wash my clothes. Yeah, just throw them in there and wash them. Maybe it could even sort your colors for you. I'm asking too much now. But right, so the washing machine's an example of a usable technology, but in some instances it isn't, but we could imagine a way that it could become more usable. All right, so now we're going to move on to acceptability. And acceptability is different from usability in that so I guess what you should write in this red box is it differs from usability because it needs to be context specific and it can't be measured in the lab. So we could think about like a smartphone. So you might have your smartphone in wherever you work, and you're making this new smartphone, and you can imagine using it in there, but that's not the context in which people are actually going to be using the smartphone in general, right? They're going to be walking around, and so if they could be in their car. There's lots of different places they're going to be with their phone, given how people take their phones everywhere, right? And so you could imagine if the only way you designed a phone as you were making it was things you cared about while you were sitting there in a design lab, then it's likely not going to be very acceptable because it's going to have features that don't make sense, right? So specifically with a phone, we can think about something that is usable on a phone, but in certain contexts isn't, like texting. So texting is very usable, but it's not very acceptable if I'm driving a car, right? So we have to think about, so the technology of texting, you could say like, oh, well, I need to think about the context in which people might be using this. And right, so people have started doing this now and going, oh, well, I'll just turn off that feature if you're in your car, or I'll do voice to text, right? So people have tried to figure out how to make texting more acceptable in some of these other contexts. And these contexts wouldn't arise in a lab. So that's how it kind of differs from usability. So some features of acceptability are, the first one is political. So do people trust the technology? Is it being forced upon them? So people often don't like things that they have to use. They like having options. So it's, you might have a technology that works perfectly, but because someone is forced to use it, they often find that unacceptable. So a recent example is, I think everyone at UVM has to use Microsoft Teams. So before that, maybe some people were using Zoom, maybe some people were using Skype, maybe some people were using something else, right? Or that was their preferred video platform, but they have to use Microsoft Teams to teach their courses. So they may not want to accept that, or that Microsoft Teams may have low acceptability And it's not because there's anything wrong with Microsoft Teams. It's simply because of the fact that it's being forced on someone to use it. And so generally that makes something unacceptable, or maybe people don't trust it as much. I don't know, maybe it's not encrypted in the same way, or maybe you don't trust it because I have to record it, and you don't want your interactions recorded. You don't like that idea of anybody being able to watch the comment you made during class afterwards or something. I don't know, right? So that could be a form of, mistrusting the technology. So another feature of acceptability is the convenience. Yeah, so is it awkward? Does it force a different path toward the user's goals? Does it disrupt their normal sensory motor processes for conducting the task? So one way we can think about this is we could think about maybe an ebook, electronic books. Those took a while to catch on. I think more and more people are using them now. I use them more than I used to, but there are some, right? So there's a convenience factor there in that I can have lots of books on there, but then you might look at this and you look at the next one, there's cultural and social habits, right? So does the technology really work with the way people like to live? And so for a book, you could imagine, well, there's some, so these are what I mean by cultural and social. It's like, well, there's not really anything like the ebook is doing the same thing, right? But there's something about having a book and using a physical book. Oftentimes people really want to have the physical book. And this can even come back into trusting the technology. So sometimes you might get a book on like a Kindle or something from Amazon, and then you're like, well, I can only use it on Kindle. So do I really own the book? Right? So do you really trust that book is yours? Where if you have the physical book, you have it, it's yours, I can see it. Right? And that could also come into culture that, culturally or socially, when we, to have a physical item, we feel like there is ownership, where if it's just in the digital world, I don't know. You can also, lots of people pirate movies and music. This could also, this plays into that. Like, why do people do that? Well, it's digital, it's not physical. Like you wouldn't go steal a movie from Walmart, but lots of people are willing to download a movie even if that's illegal in the same way, right? So these are some cultural and social things you might want to think about, especially with digital technologies. How do people feel about ownership? And ebooks is just an example of this. So ebooks might be a very convincing or very convenient, but just like he says here, do you really want to be looking at a screen? It's bright. Can you use it in the sun, right? And people have worked to solve these problems, like, you can turn down some of them. You can turn down the light, and the sun can shine on them. It's just fine, like the Kindle paper things. And then there's, what's the other people that make them? I've tried Barnes and Noble. Barnes and Noble has one. And then some other things that can make something acceptable or not acceptable is the economics of it. Is it very affordable? And so we can think about this in both ways, right? You can imagine a product that is unacceptable by nature of it being too cheap, as in, right? So there's some things, I can't think of an example right now, but there's some things that sometimes people are like, well, I wouldn't buy that because it's cheap. So they consider it unacceptable because a technological product that works really good can't cost only $30. It really should, if it's going to be a good smartwatch, it needs to be over $150. A $30 smartwatch, no. David says like tap water versus bottled water. So if I'm understanding you right, tap water is extremely affordable, but it's not acceptable. You want to go buy your bottled water, or it could be the other way around. Bottled waters, I guess you could be the other way around, right? You could imagine really expensive bottled water, and if you see someone walking around with that bottled water, you consider it very unacceptable because you paid like $10 for that bottle of water, right? Like, only someone in this economic class would do that. So that's very unacceptable. So those things come into play when we're talking about products. And then sometimes the usability of a product also affects its acceptability. So an example of this, where being more usable is less acceptable. So an example of this could be something like Facebook or Twitter. So as those things become more engaging and you spend more and more of your time on them, they become less acceptable. As in, people are like, well, that's a problem because it's addictive. Or video games can be like this too, right? So like, well, the video game's doing a really good job at what it's supposed to be doing. It's engaging, it's usable, it has high utility, it's easy to learn, right? So it's doing everything correct, and that makes it less acceptable because it has a byproduct of maybe being addictive, or you're doing it too much. It's just too usable. And people in society, that's like, this is again cultural or social, that becomes culturally or socially unacceptable. So there's some things that as they get better, they become unacceptable. Can anyone else think of something else that when it becomes really good, it becomes unacceptable, or people start to wonder if they really want it? Google search suggestions, right? So as Google gets really good at predicting what you're going to search, right? Or gets really good at showing you ads that you really like, right? As it gets really good at that, it becomes very unacceptable, right? And the cultural or social thing that's unacceptable or the political thing is trust, right? So is Google watching what I do on the internet all the time? Are they storing my data? Um, are they spying on me? We don't like it. We don't like people coming into our private, like that's private, and we have public, and we don't like people coming into our private life. So I think Google search is a good one. It's extremely effective, right? It's extremely usable. It is great at predicting what you're going to search, but that in a way makes it less acceptable. There is actually, I don't know if this is true, but there was an article saying that if you're married, that this Google knows that you're pregnant before you do. Or sorry, Google knows that your spouse is pregnant before anybody else does. So the first person to find out about it is Google, and they'll start showing you ads for pregnancy products or things like that. Because like the first time, I don't know, maybe your spouse starts buying like pregnancy tests, and then before they even have used the pregnancy test, Google has guessed that they're pregnant, right? So right. So this is something where people go, I don't know if that's very acceptable. I don't want Google showing me ads for these things before I've even taken the test, right? To know if I'm pregnant or not. So that's Google search was a good one. Anything else? We'll give it a minute, see if there's something else. Anything else someone can think of? Okay, yeah, both of these are really good. So Ryan talks about, I mean, this is kind of basically, yeah. So Ryan talks about AI being able to tell someone's pregnant before they know by doing it. Apparently, your voice might change in some manner. But yeah, we can think about AI in general. So politically and even culturally now, as AI gets really convenient or really good at things, people are starting to see it as less acceptable. Because they get worried, well, it's so easy to use, it's so usable that a government might use it to track people, or or anybody can use it to figure out things about people. So, or here at UVM, they can look at Twitter and discover things about you, like, do you have depression or things like that? So they can figure out things about your mental health, even based off of your Twitter, your Instagram pictures and the way you talk in your Twitter feeds and stuff, right? So AI is getting so usable that it becomes unacceptable, and people don't like progress, start to dislike progress in these areas where before we were like, well, I like it recognizing my face and automatically opening my phone and my computer, and but now those technologies become so usable that people start going, well, I don't know if I like development in AI. I don't, or we've got, like people like Elon Musk start saying, well, we'll all become obsolete and they'll just be robots, right? So we start to see it as really unacceptable to progress in this area, as very dangerous. Access to news outlets, as in we have as in like I can go anywhere to get news, like I can go to YouTube, like, what do you mean, Sarah? That like there's increased access to news? Okay, yeah, so that's what you do mean. So yeah, there's exactly, okay. So you do mean it that way. So we have tons of access to news. I can get my news from anywhere, from anyone. I know YouTube news is big right now, right? There's tons of people that have YouTube platforms that is just, they're just basically a news network of themselves on YouTube, right? But there's so many news outlets. It's so easy to create a news outlet that it does become, and all the news outlets are saying different things. It becomes a big acceptability problem where in general we go, I don't know if I can even trust anything anyone's saying, but all these things are basically impossible to independently verify, right? I can't go to whatever state or whatever country they're talking about and actually go see for myself if I think what they're saying is true, right? So as of news outlets, their effectiveness has grown, the acceptability, or especially in the way of trust, as Sarah says, has gone down a lot, I think. So yeah, I think that's true. So let's see what's next. Oh wait, the time. When does this class end? 7:45. Or sorry, not 7:45. 7:45 my time. 9:45 is when it ends. Can someone confirm? Yes. Okay. So we still got time. Okay. So let's move on to the next slide. Okay. So the next area we're going to talk about is engagement. So, so engaging, is it an engaging experience? Does it pull the user in? So some of the ways we can often know if a system is engaging is people will describe things like they feel a sense of immersion. So, they're reading a good movie or a good book and they really feel like they are in that world that they're reading about, right? So if they're reading Harry Potter would be very engaging if you afterwards you're reading, you're like, oh, I really felt like I was in a castle at Hogwarts, right? And oftentimes engaging means that people feel a little bit of intellectual challenge. They can be creatively inspired, right? So there's kind of like a balance there between it can't be so boring or easy that it's not intellectually challenging, but it can't be too intellectually challenging because then you also don't want to do it. It's got to, there's a balance there to find to make something really engaging. So yeah, so okay, so people will say like the time seems to fly by when they're using it, right? So you there's this this makes me think of there's a video by these guys on YouTube called Viva La Dirt League, and they make a video about Reddit. And I actually I'm not a big Reddit person, but one of the characters gets introduced to Reddit, and the person's like, don't do it, don't look at Reddit. I got on Reddit and I was up all night and I didn't sleep at all. And he's like, why would I do that? And he like goes up and starts reading Reddit, and then he's like scrolling through a couple of things, and when he looks up, it's been all night and it's daytime, right? So this is just past 8 hours and he didn't even know. So anyway, the time seemed to fly by, and I think everyone's had that experience with at least something where they get on and then they almost miss something, or they become late to something because they were using something that really was engaging and they had no idea. There's no way 2 hours went by. And then does the task feel like it's flowing or jerking forward bit by bit, right? So when you're doing something, does the next thing follow after it, or does it feel like you're kind of jumping around from task to task and really having to do these kind of context switches? So what in this case, what you're really trying to avoid is, I don't know. I mean, all of you guys have done programming, so this would be being jerked forward if you're programming something and then you have to stop because someone asks you a question, and then you go back to programming. Usually, it takes a little bit to kind of spin up what you were programming or writing, or even if you're writing a paper, right? You have to rethink, get all that kind of information back in your head, right? So that you're kind of like jerking back and forth between things, and we don't want to do that with a system. We don't want people to have to feel like they're kind of thinking about one thing and then they have to stop thinking about it, do something else, and come back. We don't want that kind of jerking. We want things to flow so they don't feel like they're making these kind of context switches in their brain. So there's lots of factors for engagement. Oftentimes people, when something's engaging, they feel like it's kind of a reflection of themselves, of who they are. Josh points out that Apple does this really well. They are able to play on your sense of identity. That so you kind of you might personally identify as someone who would use, I don't know, say an iPhone. The way it's made kind of reflects your own way the way you think about your life. So one of their, I guess maybe one of their things is they like to say things, they're really simple. They just work. It's kind of magical, right? They like to say those kinds of things. And they're playing on a sense of identity that a lot of people have, that they're like, well, I just like things that are simple. I don't, I like a easy, decluttered life. I like things to be simple. I like things that are streamlined, right? So that's kind of a sense of identity that they might be playing on there, if you think of yourself as that type of person. Adaptivity. Does the system challenge you at different levels of experience? So this is really important in games. If someone's becomes better at a game, hopefully you have some sort of way to adapt the game such that the game feels as difficult as when they were a beginner, so they can stay engaged. Otherwise it becomes too easy and becomes boring, right? So there's definitely a balance there with games, but there's adaptivity in lots of systems. People want to feel challenged. Like I said earlier, they want to feel intellectually challenged, but there's a balance. Not too challenged, not too easy. And then narrative, does the system tell a good story? Is there structure to it? Again, this is obviously games. This is important. But can anyone think of maybe something that's not a game where the technology needs to have some sort of narrative in it? Robert says teaching tools. Do you have any elaboration? You can talk or type. What do you mean by teaching tools? Oh, yeah, okay. So yeah, exactly. So there's things like so he says, for instance, like a game where you learn language like Duolingo, they use rewards to keep you engaged, but teaching systems in general do this, right? They almost create a sense of narrative as you're playing and a sense of progression by giving you little rewards. You are at this level, you are, I guess they gamify it in a way, right? So, but yeah, they definitely try and tell a narrative or a story in a way as you use the teaching tool to kind of show your progress. So that's a very interesting, yeah, that's definitely true. And that's a very good example. And if you do all these things right, you should also have a software that is immersive. Let me see what hold on, I got to get my other computer to see what he has in the red box. I can't remember on this one. In this one, sorry, just a second. So immersion. Oh, okay. The red box is just going to be another one altogether. So we have identity, adaptivity, narrative, immersion. Does the software draw you in? And I think we've talked about that a little bit. You know, do you feel like you're a part of what's happening? If you're watching a TV show or reading a book, do you feel like you're there? That's the immersion part. The last box in the red is going to be called flow. So flow is a feeling of gradual rather than jarring change. We kind of talked about that here. Is it flowing or is it jerking? There's a psychologist, I cannot pronounce his name, and I'm not gonna, it's really long too. But he has a book called Flow, and he says flow occurs between boredom and anxiety, and it pushes the user beyond their comfort zone. So I think this psychologist, he would ask professional athletes, you know, people at the top of their thing, they'd say, you know, when was your best game of tennis? When was your best game of basketball? When was your best game of football? When were you at your best? And oftentimes they described their feeling of like when they were doing their best, when they're at the top of their game, the best game they ever played, that like it was just things seemed to slow down. They were able to make things happen just the way they wanted to. When they were swinging the bat, it was almost like they could see the ball as they connected with it, and it was oftentimes they describe it as, you know, this thing that like time slows down, everything really seems to flow and move together. So you want that in your system, I guess, in a way. Yeah, I think that's good enough for that slide. Let's move on to make sure this still works. So, oh, and then so here he talks about et cetera. So what we've talked about so far is accessibility, usability. Today we talked mainly about acceptability and then engagement, right? So we want our products to be acceptable. We want them to be engaging. And then there's other things, right? So there's other things that obviously we can't list everything, but there's other things that make good systems. And then it's really important to remember that there's trade-offs here, right? As we make something more usable, it can be less acceptable. Also engagement, as we make things more engaging, it can be less acceptable, right? So really engaging video games, again, the idea of oftentimes engaging comes down to addiction. People feel like, well, it's addictive, people do it too much, so it becomes unacceptable because you need to spend your time doing other things. All right, let's move on to the next lecture. So we've got a little bit of time. Yeah, let's just kind of get started on this. So now we're moving on to the interactive system design. So now that we know we should be optimizing those things that we were talking about, we want to know some rules of thumb that we can use to accomplish this. So we're going to talk about some interactive, some of these principles that you want to keep in mind when you're designing these systems that really help achieve these goals. Let's see, what he says there? Helping people access, learn, and remember the system. Give them a sense of being in control, knowing what to do, how to do it, so they can feel safe and secure. They can feel like it suits them, right? So let's go to this slide. So he just kind of enumerates these things. They always have to find these boxes. He used to have these boxes pre-filled in. I have to go find them. Sorry about that. Okay, here they are. Okay. So first we want to talk about helping people access, learn, and remember a system. So the first one here is visibility. So we want to allow people to see what options and functions are available, and we want those to be easy to recognize and remember. We want to make things visible by using sound and touch as well, not necessarily by I think the way he talks about it is you don't want to use more ink. Your ink to information ratio should be low. You want to use as little bit of ink and present as much information as possible. And so to make things visible, we can use more things than just writing, here's this thing, touch this, right? Like there's other ways to make them know that there's something they can do without writing it out or spelling it out. And so we want those things to be easy to recognize. We want them to really see that there's something, there's a feature that they can do here, and easy to remember what that feature is or how to use that feature. So, and people have been doing this progressively. So if you notice like user interfaces for software, if you've used something old, maybe, I don't know, if you can imagine like, I'm not that much older than you guys. So like when I used to use Microsoft Word growing up, the top bar had like 4 rows of like buttons. There's tons of things to click on, right? So there's just tons of ink everywhere. And so everything was extremely visible, but right, that's in a way where there's so many buttons, they all look different. I have to remember so many icons that it's not very easy to recognize which button I want or remember how to do the things right. And so there's other ways you can prompt someone to get the function they want other than just physically showing them a button, right? So today you see that UIs are much smaller. I think there's just like 1 bar on Microsoft Word, or if you use another word processor, right? There's not all of these buttons to click on. And then number 2 is consistency. I'll just let, if you guys have something to write these in, I'll just read them first. 3 is familiarity, and then 4 is affordance. So consistency, similar structures should have similar functions, or I'll call them affordances. We haven't really talked about that yet, but and then for familiarity, you want to use language and symbols that a user is familiar with, or concepts that provide similar metaphors. So consistency, in terms of design, the way you might express this is anyone who has a Microsoft computer, how do you close out of a program? What do you do? Can anyone tell me what you do? It's the X in the top right, right? So what if they put the X in the bottom left, right? That would totally mess things up. Or if they put the X in some other place. And I'm assuming, and so Mac does it differently, right? Mac has it in the top left. So there is, if you switch between systems, they purposely have a different system so that when you get on the other one, you feel a lack of consistency, right? So if you use a Mac and you get on your Windows computer, then you're like, well, the X button's on the other side, and it just initially makes you dislike the system. And same if you've been using Windows, you get on a Mac, you're like, whoa, they switched where the X button is. It takes you a while to even learn how to close a program. You're like, what? Where do I click? Where do I click? So they kind of do that on purpose because then you're less likely to switch systems. But in general, for all I know, at the beginning, the close the program button was all over the place. Oh, advertisements deliberately move. That's right. Advertisements deliberately move how to close a program to a non-traditional spot so that you have to, I noticed this, you have to search around, right, to get rid of the advertisement. You're like, how do I get this to close? Where did they put the X button? Right, so this is something where obviously there's reasons to specifically break consistency in the terms of ads, but in general, when you're designing something with in other places. And so in 3, familiarity, when you're using similar symbols, another thing, this is kind of also consistency, but you know, if you go to a website, there's a couple, usually at the top, right? This is consistency, it's at the top. There's a couple tabs or a couple little text things, and you know you should be able to click on those to go to different things. They say like home, about, products, whatever. And then there's usually one in the top right that is 3 bars, right? So this is familiarity. At the beginning when someone did this, probably people weren't familiar with it, but now everyone knows the 3 bars mean I can click on that to get all of the other options, right? It's a symbol that means menu or menu items. And so the first person to kind of draw these 3 bars, that didn't mean anything, but now it's a symbol that people are familiar with. So you want to use similar symbols. You want to have consistency. People tend to place that symbol in the top right or the top left. So on your site, you don't, if you made a website, you don't want to put that on the bottom right, right? So these are things that you have to keep in mind when you're designing a system. Let's go back to the visibility one. There's this kind of cool demo that Josh does right before we finish this class with visibility. So recognition is easier than remembering. So if you look at these 2 pictures, I'll give you 1 minute, see if you can figure out how many things are different between the 2 pictures. What are the differences? How many are there? And you just keep the number in your head. Just keep it to yourself. How many differences you think there are? Okay. So now what if I do this? Oops. Now can you count how many differences there are? So here what we're talking about, if you can see it flipping through back and forth really quickly, is when I do this, it's really easy to see what has changed from picture to picture. And as I go back and forth, you could imagine just counting these, and you can get the right number fairly quickly. And so what we're doing here is we're making something visible by taking a process that's natural in the human body. The visual system naturally attends to things that appear to be moving, and we're making it easy to see the changes between these 2 pictures by using that visual system. And so that's again a way that we can say we can show a difference between things without resorting to text. So most people, if they wanted to point out the differences between these 2 pictures, they'd probably draw red circles around everything on the screen, right? They draw a little red circle around, if you that baking sheet, there's like a floppy disk thing, they draw a circle around the floppy disk on the right, and then they draw a circle around those bananas to the left. There's 3 bananas, not 2 bananas, right? They draw red circles. But there's a different way to show users something without increasing the amount of ink. And in this case, we could use their natural visual system to show them, things are changing. Or you need to attend to this with your eyes. You need to pay attention to this because something's moving on the screen. So we'll end there, and Josh will pick up with these slides again. And let's see, he'll do that on, when's the next class day? It is on, so your next class is on Monday. So I guess Josh will see you then, and yeah, I guess you guys can go or do what you want, or if you have any questions, you can ask any questions now. I'll do my best to answer them. Thanks for letting me lecture with you guys today.